Hello guys, what's up everyone? Welcome back to the channel. In today's video, we've got something super useful for any developer or even seasoned developers looking to write cleaner, more efficient code. We are going to talk about the difference between bad code and clean code. We will choose Python as a programming language in this video. And trust me, this is going to make your coding life a lot easier. So by the end of this video, you will not only be able to spot bad code, but also know exactly how to clean it up so it's more efficient, easier to read, and way more maintainable. So normally we are going to go over some common mistakes that most developers, including myself, make and how you can improve them. So before we get started, grab your favorite drink and start coding. So let's start with something every developer has encountered. Let's start with long functions. So long functions, sometimes we end up with one giant function that does everything at once, like this one you see here, for example, which make it hard to understand and maintain. So this is an example of bad code. As you can see, this function process data is doing multiple tasks. First, it strips and lowers the case of each element in the data. And then it removes empty strings. After that, it removes duplicate using the set function. And at the end, it sorts the data and prints the result. So what's wrong here? Well, this function is doing too much. It's working, but it's doing too much. It's hard to figure out what's going on. And if we wanted to change any part of this, we would have to dig into the entire function. So just to make sure, let's see if the function is working or not. Of course, here gonna just say Python long functions.py. You can see here it does everything and what the code, have stated there. So it removes, it sorts, all the functionalities are done in one single function. But now we want to make it clean. So we have to clean this up. We can break it down into smaller functions, for example, each handling just one thing. So in order to do this, let's comment out this function here and keep here the same, these two lines of code just for printing the result. As you can see, this is the previous result here. And what we're gonna do, we're gonna have one function that does one thing. So the first thing is cleaning. So here, let's put the first line we have here in this function to clean up our code. So we can call this clean data, of course, and it takes, one parameters here. And then we can return, the results here. So all we need to do is just copy and paste this line that, as I said before, strips and lowers the case of each element in the data. So let's return it here. And after that, we're gonna write another function that does the second operation. So this function should be called something like remove empty values here, data. So after that, we can just return the second functionality that we already have in our bad code. Sorry for telling it bad code because it's code itself. Anyway, so here we have this, we have two functions that takes care of two things. The first one, it strips and lowers the case of each element in the data. And the second one, it removes empty strings. So after this, we will need another function to remove duplicates. So like we have here in the third line of this functions as the third operation, of course. So here we're going to say remove duplicates. As always, we take always the same parameter, data, and then we're going to return the functionality. So all we need to do is to say list, set data here, and of course we got what we want. So after we remove duplicates, we need to sort, the data and print it later. So in order to sort this, let's begin with a function as well. So we can call this sort data. And as always, it takes data as a parameter here, and then we're gonna just do data sort, right? Like we used to do here. And after this, we're gonna return data. So that means that, so all we have here is sort data in general. So now let's have a function that groups all these operations, so in that way, we're gonna have very easy to read and clean function to understand. So here we're gonna have just something like process data, for example. And this data here should be something like this, process data and takes one parameter. And of course, here we can just say, well, so we have data as always. We can call this clean, the first function that cleans. So of course, it takes data here. And the second part, or the second function is remove empty data as always. And then we have the same for remove duplicates. So we can just say here, remove duplicates and sort data as well. So here we can just say sort data, right? So we can just have here data over there. So just to assign it to the function and the same as well for this part. So in that way, we can just say process data that we want and make sure everything is working. So in order to do this, we just need to have print here and, just say process data, or just put it like this, here's way. So let's put here uppercase as well. And yeah, let's put here and comma and print the value. So that's it. So here each function does just one thing. So this makes the code cleaner, easier to understand, and easier to update as well. So if you wanted to change how we handle duplicates, for example, we wouldn't have to touch the rest of the logic like what will happen here. But instead, we can go immediately to this function, remove duplicates, and we will just modify it based on our needs. This makes the code easier to maintain later. So let's test out, the result here and make sure everything is working good and it gives us the same, output like we got in the first example that showcase the bad code. All right, so in order to do this, let's save the file and run again the same command, long function here. And as you can see, we have code, hello Python, world, the same result of the first part. So that's the second example. Let's move now to another use case, and I think it's more frequent as well, like long functions, which is nested loops. So nested loops, let's talk about this as well. So nested loops in general are very common in programming. So but they can get messy quickly. So especially when there is a complex logic inside. So let's see this example, for instance. So it shows a bad example of nested loop within function. So in this code, we have a nested loop. So the first loop you see here is going through each order, and the second loop is going through each item in the order. Within these loops, we have two, if conditions, as you can see, that check if the item is expensive and its quantity is greater than 2. This is perfectly fine, but let's think about how we can improve it. So let's make sure if this code works or not. So all we need to do is say, well, Python as always, and the name of the file is nested loops. As you can see here, order 1 contains an expensive item with high quantity and so on. So what we want to do now, we want to make it clean. Like we did for long functions, we want to do the same for this example. So let's comment out, this example here, and let's go ahead and write a clean code for this. So in order to make it easy to understand, easy to maintain, let's have, separate functions. So the first one we can call, its expensive item, for example, uh, just to create for as, a helper function. So in order to check, specific conditions and in the items before processing them. And if we wanted to change how we define expensive items, we can simply modify one function instead of for writing, the logic in multiple places. So this might reduce the applications and makes the code more maintainable. So let's get started with the first, function here. So we can check whether an item is expensive or not. So here we have is expensive item. So of course it takes one parameter, maybe yes, something like item, and then we can return here, well, item, of course the price. So we can just put here this condition. So always here to check if there's price there, and also the second condition here, which is the quantity as well. So now we have a function that does the check, to check whether the item is expensive or not. The second function will process orders. So let's call this process orders. And it takes, as always, orders parameter because this will be a dictionary, as you can see here in this example. And of course here, let's have only one loop, which is for ordering orders. And then we can check or run the checking function that we wrote here. And then we will continue with the rest of the logic. So here we can just say for order in orders, as always, we just say expensive items, right? And this variable will, you know, go for the expensive item is expensive item function that we already have to check if something is expensive or not. So in order to do this, let's have just item, for item in order. So here in a very shorthand way. So we can just go here and say items. After this, we will run our check if is expensive. So the function that we wrote here, so that do the checking for us. As you know, this one takes one argument here. So let's pass this item as an argument. And of course here for item, so we forget, sorry guys, here item in order. And so here for item in order, items like see here, we will check if that item is expensive or not. So it will search for the price, quantity. If they meet, the conditions, then we will return this as an expensive item. So here, after we did this operation, all we need to do later is to find for item inexpensive, uh, you know, items, as always. Then let's branch, the value we want to print as always. So this one, order ID, and sorry guys. Great. So now we have by creating, a separate function, or let's say helper function like I defined at the beginning, is expensive item, we have made the code more readable compared to the first one. So now it's clearer that we are checking for specific conditions here in the first function before processing them. So if we wanted to change how we define expensive items, we can simply modify this one function, as I said, instead of writing the logic in multiple places here. So this might reduce the application and also makes the code again more maintainable. So let's test this out and see if it gives the same output as the bad code example gave. So here, let's run the same command, nested loops, and see. That's it. So order 1 contains an expensive item with high quantity, and order 2 expands yours as well. Great. So that's for the second, example of a common bad code example that might arise for every developer. So let's go to something more, common too, which is hard-coded values. So hard-coded values are something common too. Personally, I used to go through these, problems or through these mistakes before in my experiences and every time I wrote code, and we have to talk about this as well. So when you see values like numbers or strings directly written in your code, like in this example over here, that's called hard coding. So you might see this hard coded value like this or a string, like, any string. So this bad mistake can cause problems because if you need to update those values, you might have to search through your entire code base to change them. So now we have just one, very simple file, but imagine this file contains 1,000 lines of code. You have to search. You should search through your entire code base in order to, update these values. So here, this is an example of bad mistakes many developers, including myself, made when we code. And here the value, as I said, 3.14, etc. is hard-coded. And what if we want to update the value of P in the future, for example? We would have to change it in multiple places too, so this is not ideal. So let's clean this by using a constant for p. A constant is a variable that doesn't change, and we can define it as in the top of our code, so it's easy to modify later. So let's do that very easily here by, yeah, let's comment out, this code. And here we can have just something p there, and we can call it, 3.14, blah, 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 right? And then we can have, our two functions, calculate area, calculate circumference. So these functions are important here, so because we need them to calculate area and circumference. But here we're going to change just the value of u and we'll assign the variable instead. So here we can just say p and the same as well for this. Great. So now we have, the same. So this will not make any impact on or any change on our code. So let's run this and see if it gives the same, So here it's hard coded, sorry. And here we can have this. So you can see the area and circumference as well. So that's, clean now. Now we have made the code cleaner. And if we want to update the value of p, we only need to change it in one place. So, and the rest of the code will automatically use the updated values. So this makes it much more easier to update and maintain in the future. So that's for the three common mistakes: long functions, nested loops, hard-coded values. But what about the repetitive code? So repetitive code is another thing that can make your code messy. You know, it's repetition at the end. So if you find yourself writing the same code over and over again, it's a sign that you need to refactor. So here is an example of bad code. For instance, we have three functions that calculate salary, bonus, and total income. So in this example, we have two functions. So calculate salary and calculate bonus. So both perform a multiplication. And this logic normally is repeated, right? So we can simplify it by creating a helper function that handles the multiplication for both cases. So let's give a simple, use case for a clean code example using the same, logic here. So let's comment out this code. And here we can, for example, have, or let's say the purpose now is to extract the multiplication logic into a helper function, like we did for the previous example, nested loops. So we're gonna have like a helper function. So, and this helper function will calculate the amount. So in order to do this, let's have a function here, calculate amount. Sorry, here, diff. Right? So, and this will take, two columns. So we have rate and quantity, sorry. So this will return, the multiplication process. So rate times or multiplied by the quantity. And then we're gonna have the second function that calculate the salary. So here we have this function. So let's copy it and paste it. So here we're gonna just comment it. And we have, as we know, calculate amount that calculates the amount based on rate and quantity. So all we need to do now is to pass this function here. So calculate amount here. And also we need to give this function to parameters that needs. So here we have salary. And also we have bonus percentage. Okay, so we can say bonus percentage. Okay, and here we will just pass, the value as well here, salary and the bonus to divided by 100, to get the percentage. And after this, we will calculate the bonus. So the bonus here is going to be completely, you see we change everything. So we refactor our function here to do things right and in maintainable way. And now let's have another function, like I said, to calculate the bonus. So here the bonus is gonna take, two uh in general here for the bonus. I'm sorry, for salary, because I made here a mistake. So let's put, yes, this one is the one that calculates the bonus. I'm sorry. But now we need a function that calculate the salary. So here we can just have, salary. I'm sorry, guys, I confuse you here. Okay, so let's make things clearer and return here, the salary that we want. So we're gonna use, calculate amount, of course. So, but we write this separate function for calculating the bonus, right? And here we have calculate amount, and we're gonna just do hourly rate as always, because this function should accept these params. So hourly rate, and then we need to set as well the hours or the number of hours worked. Okay, so after we do this, all have to do now is to pass, these parameters to calculate amount like these, like this in general. And then now we have one operation left is calculating the total income, that depends on hourly rates, hours worked, and bonus percentage. So let's copy here everything. So because this function won't change, and you're gonna just have it here. So it's already did the job for us. So let's just copy it like this, and yes, that's it. So now we have calculate salary, calculate bonus, salary bonus percentage there, hours worked, and salary plus bonus for getting the total income here. So we have this branch by which we can use to, get the output. So let's save the code and run the command python repetitive code.py to see if the code is working and it give us the right output. So here, we have one missing argument. So in calculate amount, maybe I forget to put the quantity here. So calculate amount. Of course, I forget that in my code. So here we have quantity. So here, as I said, error, it said calculate amount, missing one required positional argument, which is quantity. All right. Oh, all right. I see what I did wrong here, guys. I put here the comma here instead, so I should put comma because we have a new variable for, sorry, new parameters for calculate amount. So let's run the code again and see if that will work. So here, let's clear everything and put Python here. So as you can see here, we have total income. So we are calculating right now the total income. I don't know why it's, oh yes, I put here too. Okay, guys, I'm sorry. All right. So that's, a very good example on how to get rid of repetitive code in our, in our code base in general. So it's a very simple, example. I hope it's clear and, you know, it's very useful to you guys. So now we have extracted the multiplication logic into a helper function, and called calculate amount. And this will reduce, the duplication and makes the code easier to maintain. So as always, if we need to change the calculation logic, we only need to modify this one function, so based on your own needs. So now let's go to another common mistake and use case, which is too many parameters. So too many parameters, I have included here a little example so that showcase this common mistake as developers we make in day-to-day basis. So functions in general with too many parameters, like in this example, can get confusing, and it's hard to remember the order and meaning of each one. So this makes the code less readable, and also not hard in general to understand. So here we have a function, create a user, that takes 7 parameters. So it's hard to know what they all represent just by looking at the function, signature. So to clean this up, in general, we can use a class to group related data together. So let's build this together here. So all we need to do is to comment out this code now, and oops, I don't know what's going on here. Hmm, there is a little problem happen. Anyway, so guys, so here we will write, a user class so that group, all user related data into a single object. So let's do this. So here we can just say class user, um, course, and then we can just run, a little function that takes only those parameter that we mentioned already. So here we have self, we have first name, last name, email, password, and age plus address and phone number. So in order to do that, let's put here, in it as always for the class in general. And here we can just say, well, self, it takes all these things. So let's have, first name. So we're gonna just copy everything here, right? And of course, for address, we can make it, for example, accept non-values, and font the same as well, be non-true. And after this, we can just, initiate our own values here. So all we need to do is self first name, and put here name, and then we can define our value first name. So, and the same we can do for all the examples that we have. So last name, email, password, age, and so on. So after we did that, so we have here first name, last name, email, password, age, address, and phone. So let's create, a function that only takes one parameter, which is user data. So this will make the code, as I said, cleaner and more understandable. So in order to do that, let's go and say, for example, div, here, create user, right? So this will take user data. And of course, here we can have a code, just have like comment code to create the user in general. Okay. So in that way, we just need to pass here everything. So we can write the logic we want, in this function to, create the user. So this is just a very simple example to make the code, cleaner and maintainable later. So now we ended up, the too many parameters use case. So let's go to another example and another use case that it's also common, which is, built-in functions. So for the built-in functions, it's the last thing we have in this video to talk about. And as you know, Python has a lot of powerful built-in functions that can make your code cleaner and more efficient. So this is an example of bad code that finds unique numbers. So here we are manually checking if a number is unique by looping through, the list, right? And this can be very inefficient, especially if we have a large list. So not like this list here, but imagine we have a list of, all dictionaries that contains, thousands of data. So it can be hard, to use this um, manual approach to find unique numbers. So here instead we can use Python's built-in set function, which automatically removes duplicates for us. So in order to do this, let's comment out or let's run this code first to make sure it's working. So here it's built-in functions. So of course here we have 1, 2, 3, 4. So it gets rid of 2 and 1 because they are duplicates and it sorts for as list, etc. And append everything there and it does the rest of the logic. So here we can do this just with this, all we need to do is to write this set number, the set method, use it inside our function. So let's put here find unique numbers, right? And we can give them a list numbers, of course. And here we can just return list, you know, um, as always to, as I said, organize our list and convert it to a list of numbers, and then we will remove duplicates with set. So set here, it accepts numbers as an argument. So now the code is much cleaner. So if we run it, always with the same command. So here I forget to put find unique numbers. I'm sorry. So let's run again the command built-in functions and you can get, 1, 2, 3, 4. So now the code is much cleaner and it runs more efficiently because we are using Python's built-in capabilities instead of reinventing the wheel. So that's it. So for today's video, on bad code versus clean code. I hope you have learned some valuable tips on how to write more maintainable, readable, and efficient code. So if you find this helpful, don't forget to hit that like button and subscribe to the channel for more coding tutorials. Also, if you've got your own tips or questions, drop a comment down below. I'd love to hear from you. So thanks for watching and happy coding.